Namaskar, my dear friends. Let us talk about how we can utilize current sources in multisim. So there are various kinds of sources that we generally need to utilize in circuit designs. Like we need to have DC current source or AC current source, pulse current source. We have a step signal in current sources, or the last one will be piecewise linear function, that is PWL current sources. So as you can see very nicely, we have a current source of 10 milliampere with a load resistance of 10 kilo ohm. So this is my DC current source. Similar to that, we have AC current source of 10 milliampere current rating and 1 kilohertz frequency. Similar to that, we have pulse wave. Okay, so like signals are there. Otherwise, you can have a step signal, like at a particular time you want to start a pulse, or otherwise you have piecewise linear function, that is your user defined function. So why don't we do one thing? We can open multisim and we can simulate each one of them and try to see how we can get all these current sources one by one. So let us open a new file. So go to new blank, create a new file. So in this, to put a source, what do we do basically is go to place components. Here we have all groups. In this all groups, generally what we do is we go to sources and then we go to power sources. So you have a lot of voltage sources and all. To get a current source, we have signal current sources. Okay, and you have controlled current source as well, that we will talk about later on. However, our aim is to go into signal current sources. In this signal current source, we will first talk about DC current. So we have a DC current here. So select this one and press OK. So the DC current will be placed. Then I'll just make it little bigger so that you can view it properly. Okay, now let us go to power source and put a ground first, because we need one ground here. And then go to basic and put a load resistor. So let's say load resistor 10 kilo ohm, I can put it. So press Ctrl R to rotate it. That's all. So this is how we have completed the circuit. Now quickly wire it up. Go to the pin and just wire it up quickly. Okay. Why I am putting a load resistor? So that the current will be not open circuit. Okay. That's all. So you can see we have 1 ampere current and we have 10 kilo ohm resistor. Now to check this, what we can do is we can put a current probe. Okay, so emitter probe we can put. Go to emitter and put a probe here. So you can see it is done. Right. Now let us do one thing. If you run it, what is going to happen is it will come -1 ampere, because the current probe direction is opposite, because current is this direction, however probe is put in this direction. So that's the reason it is giving you -1 ampere. If you want to see it in a graph, what you have to do is go to simulate, go to analyze and simulation, and then select the transient simulation and run it for any like time that you want. So let's say 1 millisecond I am running and press run. So you can see very nicely -1 ampere is appearing at this particular place, because it is 1 ampere and it is opposite direction. If you want to change the trace width of like graph, you can go trace width, let's say make it 4, so it is much better. Now to change the value of current, what you can do is select this particular current source, double click it and change the value of current that you want it to be. So let us say I want 10 milliampere, that is 0.01 ampere. So it will be 10 milliamps. Now if you run it, the current will become 10 milliamps. Understood? So this was all about DC current source. Now let us talk about AC current source. So what I'll do is I'll take the same, I'll just put it here. Okay. Now I'll delete this current source and I'm going to put AC current source. So go to place, The group that will be there is sources, signal source, we'll put AC current source. Okay, now I'll just quickly wire it up. So remove this. So we have 1 ampere current source of 1 kilohertz. 1 kilohertz means 1 millisecond. So if I am running for 1 millisecond time, it will give 1 pulse. Okay. So let us run it and see. I am putting probe here so that it will give you. Now let us run it. So you can see 1 pulse is there and it is starting from negative because the current, like probe is negative direction. Okay. Let me make it positive direction so that it will give. Okay. I am making it positive direction. Now it will give me. So see, current is flowing downward towards the resistor. So that's the reason it is giving me positive direction. And you can see it is 1 ampere up and 1 ampere down. If you want to have more pulses, what you can do, quickly change the simulation setting to be more number of time, let's say 5 millisecond. So you can see 5 pulses are there. Now let us see what is the properties of this AC current source. So in this AC current source, let us say I want to make it 0.001. So 1 milliampere will be, like amplitude up and down. Then let us say I want it to be 100 hertz or 500 hertz. So 500 hertz signal is there. Now let us run it. So if 500 hertz is there, then it is going to be how much? 0.2 millisecond, right? 500 hertz means 0.2 milliseconds. So what we can do is we can run it and see how many pulses are appearing. You can see around 2.5 pulses are appearing. Okay. So that's all. This was all about AC current sources. Now let's talk about how we can simulate a pulse current source. So I am going to take a pulse current source here. To do that, I'm going to remove this as well, and take the current source as it is here. Let it be level. First I'll go to place components. What I'm going to do is I'm going to take a pulse current source. So here it is pulse. Quickly put it here like this, and that's all. I'll take it little right side, and then if you connect it, it will come like this. So you can see current is flowing from this direction to this direction, and we have 1 ampere up and 1 ampere down, and this is going to be 0.5 millisecond on time and 0.5 millisecond off time. That's the reason it is 1 millisecond period. Now if I run it, what will happen? Total 5 pulses will appear with plus 1 ampere up and minus 1 ampere down. So let us run it. So you can see 1 ampere up and 1 ampere down, it is there, and this is how pulse signal is there for the current sources. If you want, you can double click it, and let's say you want to change it to 0 ampere to let us say 10 milliamperes. So 0.01 milliampere. If you want, you can change the pulses. Okay. So let us say I want it to be 1 millisecond, and the pulse period should be 3 milliseconds. That is 2 millisecond off. So what will happen? 1 millisecond on, 2 millisecond off. Okay. And let us run it for 3 5 let's say 15. So I will put it for 15 millisecond. Okay. That's all. So if I run it, I am going to get 1 millisecond high and 2 millisecond low. Similar to that, 1 millisecond high, 2 millisecond low. And this is how you can see we have very nice current source with pulse sources. Okay. Let us quickly do other part. What we can do is I am going to take a step signal. So to have a step current source, I am going to remove this one, and same probe I am going to put here so that I see only one probe. Okay. So what I am going to do is I am going to replace this current source with my step current source. So go to place, component, we have a step current source. So step current source means what? Like at a time whenever you want, you can start it. Okay. Step current source, let me give you an example. Basically, I have already told you start at a particular time and go to step up. That's all. So to do that, I am going to quickly wire it up. And if you see, let's double click it and see what is going to happen. You can see initial level is 0 ampere, final level is 5 ampere, and step time is 1 millisecond. It means at 1 millisecond, your current source will start. So if you run it, you see at 1 millisecond, it is starting and going to 5 amperes and it is remaining there itself. Okay, so this is how it works. Now let me do one more thing. I am going to change this to 1 ampere and start it at, let us say, 3 millisecond. So if you start at 3 millisecond, what will happen? At 3 millisecond it will start and then it will reach to 1 ampere. So let us run it. So you can see my current source has started at 3 milliampere, 3 millisecond and reached to 1 milliampere. Understood? So this was all about step sources. Now we'll talk about PWL file. Okay. So PWL source, how do we do that? How do we do that is, let me remove this probe and put another source, and I am going to work I'm going to work with PWL source. So to do that, what do we do is place components. I'm going to put piecewise linear current source. So in this piecewise linear current source, you already know how to work with this, right? So first click this, and this is my source that is defined. Okay. Now let us put a probe. So I'm going to put probe this direction here. So it will be PR1. Now if you double click it, you are going to see either you can use a file to do that piecewise linear function, or otherwise you can put data tables. Okay. So let us say my current source will be something like this. Let me give an example. So I'm going to take example quickly. For piecewise linear function, I am going to define my current sources to be this. Let's say it starts 0, then it starts up and then down and then 0. Like that, this is my time in millisecond and this is my current in, let us say, milliampere. So let us say it becomes 5 milliampere and this is at 10 millisecond, 20 millisecond, 40 millisecond and 50 millisecond. So what will happen is at 10 it should be 0, 20 it should become 5 and 40 it should become 5 and 50 it should become again 0. Understood? So to do this, what do? We can go here, put data table. So data table I am going to put what? 10 millisecond, this will be 0. And then at 20 millisecond, it should become how much? Let us say 5 milliampere. So 0.005. And then till 40 millisecond, it should maintain that. So for that, what will happen? 0.005. And then at 50 millisecond, it should come to 0 again. So I'll put it 0. So this is how you see you have made your data entry table and you can do that. So now my piecewise linear current source is ready. If I run it, it will give me the result. So it is not giving you result. Why? Because it is starting at 10 millisecond. It reached to high, but it is not reaching to 5 milliampere because we have run it for lesser time. So go to simulate, analyze simulation. Since it is reaching to 50 milliseconds, so why don't we run it for, let's say, 60 millisecond. So if you run it for 60 millisecond, you can see it started at 10 millisecond, reached to 5 milliampere at 20, maintained 5 milliampere till 40, and then it reached to 0 milliampere at 50, and then it maintained at 0. So this was piecewise linear source. If you change some value, let us say it reached to instead of 5, I am making it to reach to, let's say, 10. So what will happen? There will be a step from here 5, it will go to 10. So let's run it, how it behaves. So you can see at 20 it became 5, and from 20 to 40 it became how much? 10. So to make it a little better, why don't you do one thing? From here to 30 you maintain it, and then from here to up you maintain it. Like that you can make, based on your choice you can do that. Okay. Now I am going to make one change here. instead of instead of having single pulse, I want to repeat the same source. So if the same source wants to be repeat, you have to check this. Press OK and let's run it. So same source will keep on repeating. So as you can see, we have single pulse here. So to get all the pulses, change the simulation time to little bit higher time. So let us say we run it for, let's say, 300 millisecond, means minimum 5 pulse will appear. So let us run it. So you can see 5 pulses are there with 0 to 5 milliamperes current. So this is how you have seen almost all kinds of like current sources that is there in Multisim for various utilization in your different circuits. And if you do have any questions or any understanding that is needed regarding the current sources, you can always reach out to us and we shall be able to answer you out. Thank you. Still, if you do have any question or like any sources that you want to define by yourself, you can reach out to us and we shall be able to give you answers as soon as possible.